Convocation. Welcome everyone to our second AGC IRIS-HEP demo day. The format of this is going to be similar to what we did last time. This is a meeting where we will have lots of contributions to show process and things that people have worked on over the past 2 months since the last demo day. And you'll get all the updates condensed into pretty short contributions, which are not going to be enough to do all the work justice, but it's going to be giving you an impression of everything that's going on. We're going to try to stick to this pretty tight schedule here. But however, this is an invitation for more discussions that can then be planned and can take place in dedicated meetings. So here's really an opportunity to see everything in one place, including maybe contributions that otherwise you wouldn't necessarily be aware of because they don't directly are situated in your sort of main group, in the sort of main topics you're working on. So it's also a nice opportunity to see what else is ongoing sort of on different ends of the spectrum. I will not talk any longer about this, and we're going to jump straight into our first contribution because we're a bit behind time since we started so late, but then we'll still give you the allocated time, so no worries about that. Starting the meeting, we have 2 contributions that are focused on ServiceX. One of them about support for multiple code generators, and one of them dealing with JWT tokens. Ben, the floor is yours, and I'm assuming you're going to be sharing on your end.
Yes. Hopefully, let's see. Yeah. So to start with the next 2 demos will be almost as impressive as the OWL demo. I think what we've discovered is that by adding a lot of new developers to the back end, we can completely overpower the rest of our organization and infrastructure. So both the features I was hoping to demonstrate today are complete in the back end, and front end changes that this unleashed were more complicated than we could have imagined. And so the front end, Tal and Gordon and I were busily passing new ServiceX front end packages back and forth, like up until 30 seconds before this meeting started, and we did not succeed. And so I'll talk about the disappointment of the other demo in just a second. But I can show a few broken things and show how it's all eventually should work together. So with perhaps if we had more further ado. Let's see. So the first thing is deployment. So this is something that the grad students figured out, which I thought was quite ingenious. So it used to be in, this is values.yaml. Is this a reasonable resolution?
So hold on a sec, because we actually can't see a thing in the
larger
room.
would be better.
Yeah.
Yeah, that works.
I don't know if it's reasonable resolution, but it's unreadable in dark mode.
Okay.
There is a way to do it.
There's this great. Is this better?
I mean, it's still in dark mode. So.
Yeah, I know.
Oh, that's not okay. I'm not going to be able to help with that.
All right. Whoa. I'm just going to go with.
Now.
Sorry.
It looks great now.
Great. Okay. So in the previous deployments of ServiceX, there was a single entry for code gen where you just said, I have no idea what this code generator is, but this is the Docker image to use. And when you run transformers, you use the transformer that I say here. Good enough. So what we did for this new version is CodeGen is now a list. And so this name here is the name that you would use in the front end if you wanted to use a particular code generator. You can enable or disable it. And then here's the image and the default transformer image to use and tag. And so we've got now Atlas, uproot, CMS, which is actually the CMS run 1 AOD, I think. And then Python, which allows you to just enter plain old uproot in a Python transformer. So I wonder how I get out of this.
Whoa. I can't download the API token.
Okay, now I don't know how to get out of this editor.
If you hit Control backtick, you can change the view mode. Usually. So if you go to view mode and exit presentation mode.
Oh, thank you. Ish. There we go. Okay. And the other thing to we can do what we had wanted to do, which was to have separate code generators for the different Atlas analysis space, different releases and things like that. One of the other things I'll point out is like code generator. Every code generator has a JSON file which describes what it does. So a little description, some fun things, supported file formats, and then how you run the transformer, because the xAOD transformer use Bash and C++, the uproot transformers use Python. So how do you use this in practice? So in theory, there's now a new argument to the ServiceX data set where you put in what you want and then send it all off, and it just does its thing. As it turns out, there's lots of very interesting relationships and assumptions built into the front end where it knows that the Atlas xAOD code generator can only return root files, and there's lots of complicated things that we're still working through. But it does work. We've deployed this on the integration test environment, and that's what we've got.
So, Ben, I thought you had this working with just the code gen where you weren't trying to play, or at least I thought that's what your messages said last night, was you had a version of this working. It's just not with when we attempted to do it like more correctly and more flexibly, it failed.
No, I get it to like work where it returns a file format that it's not expecting. So it goes off to the code generator, it runs, and then it returns a root file, and the front end's expecting Parquet. So as far as the back end goes, it works. It just doesn't actually return any physics.
Okay, fine. All right, let's see if we can fix this in the next 10 minutes.
Any other thoughts or questions on?
We got it to run, right? So I don't know what, I mean, on the Parquet side, I guess we haven't run it yet, so we can.
Yeah, we were able to, we can get it to run, but we can't reproduce it on Ben's terminal, on Ben's environment. So there's still something squirrely going on, but Tal and I were able to actually make that snippet of code that Ben has work.
Honest. So interesting things like next steps. So I think it's going to be fun to see what happens with the Python code generator, whether people like using uproot, whether that, I think it solves something, backdoors that we wanted to put into this. The other thing is, I don't know if there's any applications for this, but now we could have a xAOD transformer produce Parquet files or flat root files, and then use the uproot code generator to do some further cuts or things on it. Who knows? Another thing we wanted to do is the Atlas open data set tends to publish everything with zip files. And so we haven't been able to really use those in ServiceX. So we could write a trivial unzip transformer, and then a second pass would then to use whatever comes out of that and run that through a transformer. So anything else on this? Otherwise, I'll go on to the non-demo of self-signed JWT tokens.
I have one thing. On Zoom, please also feel free to raise your hand, and we can can get through that. If you go back to the file where you have these information about the different code generators, for the Python one, I noticed the like science image was the xAOD one.
Oh, that's wrong. It should be the uproot.
All right. Okay. Yeah, I was wondering if there's some like use case here with xAOD. Okay. Perfect. Then.
Yep.
Easy question. Okay. Anything else here on that first part for Ben?
Maybe just like this file would be perfect actually, that we could, if there's some nice way of doing it on the front end, to just inherit from this and have you know, the naming of specific code generators, etc., and the related image name, just inherit from this, so that if any dependency here changes on the back end, that it will just automatically be right in the front end, and it also makes I don't know, it makes things just nicer.
There's actually a new REST endpoint in ServiceX that we're not using that'll return this. So you don't have to get this file. You can just talk to your ServiceX and figure out what's going on in its deployment.
Then
that's perfect.
It might be very cool to add that to the CLI, the command, so somebody could just from the command type, you know, I don't know, code generators or something like that, and then it would just list the available code generators.
Yeah, although you have to be authenticated. I guess we could take that out of the authenticated. There's no reason to make that a secure thing. But okay, yes. Good idea.
And there's probably other implementations that we can do that sort of reconcile any potential divergences between the front end and the back end related to this, because yeah, there is simply a non-trivial amount of different names and different file types that are only compatible with specific other types and other names, and so this would be a nice way to have that not be potential, you know, cause potential divergences later down the line.
Okay, so then anything else on this one? I don't want to steal time from all my other colleagues. So the other non-demo is we made a modification to the front end library so that it follows the WLCG guidelines for tokens, bearer tokens. And so the problem has been that if we're running inside the analysis facility, we don't have a way of just managing users internally. We'd have to have like there's already a user management based on the Atlas and CMS tokens that are available inside the analysis facility. And so there's a whole duplicated user management problem. So Brian and Oksana helped us find there's a WLCG standard that has an environment variable that points to a file that always has a current token available for you. And so we modified the front end library to see if that environment variable is there and that file is available. It skips the rest of the authentication stuff and just uses the token from there to talk to ServiceX. And so we have a not quite working deployment at the Atlas analysis facility that has the correct library, picks up the token, and then we're just trying to configure a ServiceX with a correct secret that token would unlock. And I see out of the corner of my eye, Brian Bockelman with some suggestions on what we did wrong. So that's almost there in the Chicago analysis facility. It was fairly simple in the end with some great requirement specifications from Brian and Oksana. So nothing to show there either.
How portable is this solution to other facilities? How specific is that for Chicago?
Certainly any Coffea-casa facility. So it's relying on this WLCG spec that says where the token is available.
Okay.
So close.
No worries, Ben. It's demo, you know, it's always like this.
And like I said, we've definitely seen where we're pushing the deployment organization too hard with trying to keep up with these major releases, major changes. and then the front end development and things like that. So
That is okay. I would rather have us be pushed than not. But we'll get this fixed.
Yep.
Obviously.
all right, that's all from me.
Thanks a lot, Ben. Let's see whether we have other questions, other comments. Okay, I think if there's nothing else, then we are going to continue, given that our timeline is has lots, like our agenda has lots of contributions. We're continuing with Lindsey, who's going to be talking about Awkward-dask and Coffee. And Lindsey, before I give you the floor, one thing I forgot to mention initially with all the room microphone issues, we have a Google Doc, which I linked in the chat. It's also linked on the agenda. Feel free to use that for any other points we want to track. We can get back to this afterwards if you can't fit all the discussions in here. And yeah, with that, Lindsey, take it away.
All right, cool. So yeah, I'm going to give you a demo of what's going on with Coffee and Awkward-dask. Excuse me. In particular, we're to the point where a release is imminent, and the implications of this are really interesting, especially with respect to ServiceX and some other things in the wider ecosystem, because the task graph that this renders underneath the hood is fairly easy to manipulate, and you can go in and slice and dice it and do fun things with it. So you can imagine building larger workflows out of what we're going to do here. And the other kind of interesting thing with all of this is that it obviates the need for a trivial MapReduce style of computing like we do with coffee processors, because we now have a way to completely trace an entire analysis into a declarative format. So that being said, let's see something cute. So it's a raw MET distribution. It executes suspiciously faster than just doing it with Dask than just doing it in uproot. And this is because the native Dask executor that gets spawned when you just ask to do things in Dask is multi-threaded, and it takes advantage of that immediately.
Sorry, Lindsey, it looks like the times are exactly the same. Did I miss?
You are
1.15
and 1.15.
1.58, and then what was the other one? 1.58? Oh, 1.5. Okay.
Yes. And this is a completely IO bound thing. There's no compute going on, and we don't see any issues, or well, this won't expose any of the major issues with the GIL locking if they exist. So out of the box, it's already faster. Out of the box, it's already distributable on a cluster as compared to the next statement. And if you wanted to, you could also interrogate this thing for, move this stupid window, get out of the way. Yeah, you could interrogate this thing for a task graph. So let's see if we were to just copy paste this right here. We can also do this. So that's really hard to see, sorry. But what it is it's a essentially a automatic MapReduce and then tree reduce of histograms over all of the chunks of the file that were passed in. And then this shows you the unoptimized graph. You can also optimize the Dask graph, and it gets rid of pieces and parts of that graph that just represent operations that are manipulating the same data, so you can fuse them all together into a single step.
So Lindsey, you mentioned file chunks. There's a root file there which has natural file chunk boundaries. Does it understand those, or is it just somewhat arbitrary? 10,000 at a time.
No, you can say to to uproot.dask in this case that I want this in 300 megabyte chunks, or you can also offer another number of events that you want to chunk it into, and it will work around it will work around the basket boundaries that are in the root file.
So there is some understanding between Dask and uproot of the inherent structure of the root file.
I mean, it's a chunking that you set. I don't know if there is a thing that says just chunk this by the basket structure. You could probably put that in there. It would be easy to do. But but right now you can kind of control it either by specifying a number of, either by specifying a memory size or a number of events that you want inside a chunk. And then uproot itself will deal with the chunking and the issues of the chunkings overlapping like basket boundaries and things like that. The answer to your question is yes. Anyway, any other questions before I go on? No. All right. So what's even more cute than making a trivial matplot? Obviously, it is making the entire set of jet energy scale systematics with B tagging scale factors and something that looks moderately like an analysis using this and seeing what it does. So we're going to do that. And so first thing we're going to do is load a metric ton of metadata. That's all the corrections that we're going to apply. Then we are going to, and this is a new feature as of the last about week and a half, create a full nano events representation of this particular root file in Dask. And if you want me to do it later, you can also do .star and glob files, and I have 100 of the same file replicated to show that this actually scales. And so we're going to make nano events. These nano events work like you might expect. So events.particles adds. Right, it's gen parts. How about that? 13. So yeah, it understands how to do cuts on gen particles recursively across all the gen particles in the event, and maybe we want to compute that too. And look at that, we got the PT for all the gen particles that have PDG of 13. So that's pretty nice. That means we can do a lot of other things too, like gen match jets automatically, do jet to electron cross references, and calculate jet energy scale uncertainties. So now you're going to see a whole bunch of boilerplate, and that's setting up what things we want to load and what mappings we want to apply to our data in order to tell it where to get raw values and pieces of information that are necessary for making corrections. We're going to get, excuse me, get a jet object out of the event, add a little bit of annotation to that in order to have the raw PT, the generator PT, the match generator PT, and the fixed grid row for all of the jets broadcasted out event-wise. And then we're going to make the corrected jets factory with all these mappings inside of it. And then we're going to build the jets. So that took half a second. That's great. And now we can do some interesting things on that, like analyze the number of columns that it needs to read in. And you'll see that it is selective in some cases, like it knows it only needs the gen PT down here. It's loading the entire jet because there's a bug. And we'll be able to, and that's something that we're working on right now to fix and make a little bit more concise, because this should really only need like PT, eta, phi, rho, and a few other things about the jet rather than everything in the universe. So what does this task graph look like? Why did it take a half second to calculate it? And what's going on underneath this? Yes. So you will notice that if I try to visualize it, it's taking a little bit. Give it a second here. Yeah, so that's what the complete task graph for a CMS jet energy scale correction looks like, including all of its systematic uncertainties that are lazily evaluated when you ask for them, and then ask for a dot compute from Dask. So you can see it reading from the file, doing a few cuts to start off with, and or a few manipulations and cuts to start off with, adding in various fields that are interesting. And then this giant tangle of connections in the DAG is what's going on inside the jet energy correction. And it's nice to have it exploded like this because it's easier to debug that way, because you can actually go to the node in the task graph that says what it is doing and see if it's actually being executed. But you can also ask the visualization to optimize the graph, which is the default for when it runs compute. And you'll see that it collapses all exactly into one operation, which is nice. And then maybe we want to calculate that too. And you can see that we get all the corrected values in this case. If we want to interrogate that a little bit and see what the uncorrected value is, that's not, I believe it is. Yeah, so you can see that there's been corrections to applied to all of these jets, correcting the PT up and down, depending on what part of the detector it is, what its local conditions look like, all the other things that go into correcting jets on CMS, and what PT it is, etc. I could also show you the same thing for missing ET, but that's evaluated in the notebook that's on Indico. But suffice to say, oh, right, I didn't. Let me make this. And then let me show you how long this is. This is a even longer task graph that does even more stuff, because it's doing sums over jets to correct the missing ET, instead of just giving you access to individual jets. Now, let's go to doing what I was talking about at the very beginning of this, which is correcting the jets and then filling a histogram with a B tagging scale factor in this case. Let's just assume we've applied some MBA, in this case, deep double B from CMS. And we're working with the medium working point on the, and we're calculating on the central value of the B tagging uncertainties, the systematics over all of the jet kinematic uncertainties. Takes a little bit. There's some things we need to chase down in correction lib where it seems to take a while in evaluating a length 0 array. So we'll figure that one out. And that took 10 seconds to build the whole task graph. If we want to see the task graph that we built, where are you? What's your name? Right. So I don't want to print out the whole thing. So that this is from 10 lines of code, a 2000 node task graph. Let's see what it looks like if it's optimized. Import oh, right, and that returns tuple. So how about that? What do you get? Oh, come on.
Yeah, I saw that.
Yeah, there we go. So it turns that 2000 node task graph into one of length 333, and it is mostly calculating histogram fills in parallel that could on it, or that could, and I can show you what the graph looks like and why that is happening in a bit. And this could actually be splayed over the resources that you have in a cluster, and hence you could save time in iteratively filling those histograms. So this is the first departure from standard MapReduce, where we see for a given data set that within it we can parallelize over the systematics, which is something we've never been able to do before from like the computing infrastructure standpoint, which is really cool. Going on. So that took 2 seconds, and we get 111 variations, because that's which is the right number of variations to get in this case, because we have 55 systematic uncertainties to evaluate, and we were able to calculate all of that in 2 seconds based on this task graph that we built in 10, because this is only reading a 40 event file. But let me recalculate this task graph to get something that's a bit more tractable to print on a screen, and reevaluate this guy. Are you gonna, oh, you're gonna be angry, okay. Let me restart this then. and rebuild this. And so I'm going to take this task graph and parse it down to only the first 3 systematic uncertainties. So we've got that, and let's look at what the task graph looks like now. And you can see there's adding all of these histograms together iteratively through each stage. And what's going on at the very beginning of it is that for each systematic that we're asking for, including the central value, it is allowing this fill to be done in parallel on the processing, on the compute infrastructure that you give to Dask, which in this case is the 10 cores on my laptop. So yeah, that's the end of it. Okay, I didn't define out because I didn't calculate it. Good job, me. And yeah, you can see here that the output shape of the histogram is also changed, and that's correct because we have 3 systematics and then an up and down variation for each plus the central value, and then there's 42 PT bins. So all of it's consistent, and that's it.
Thanks a lot, Lindsey. It's really exciting to see this every time and really cool to see those Nano events working. Are there questions to Lindsey?
So what for a user that is a occasional usage or occasionally works with coffee, what do they see here? Is it just everything goes faster, or things are slightly faster, or what's the elevator pitch selling point behind actually having Dask peel into the computations themselves?
So the elevator pitch selling point is that you will be able to get better parallelism, as you say, because you can do the splaying over systematics. It allows us to access, let's say, compute or patterns of developing your analysis that we just don't have without this, like organizing your analysis by systematic uncertainties on the outermost loop as opposed to the innermost loop, which makes your bookkeeping for doing statistics easier. And then on top of that, the only difference that most people will ever see is using the Dask histograms and the Dask arrays and asking for dot compute, as opposed to just getting the array out. And then on top of all of that, one thing I didn't go into here is that once you have everything in a Dask array and into the Dask infrastructure, you can do dynamic casting, you can do skimming of your analysis in situ and create derived data products or caches to share with people who are using the same Dask cluster, so that you can get just a significantly more efficient analysis workflow after you run it the first time, and if you keep your Dask cluster alive. So essentially, this is kind of the gateway to the it's the gateway to all the stuff we want.
Yeah. I mean, to be honest, from the 3 things you mentioned there, it sounds like the parallelism is almost the least interesting one, right?
Yeah, especially depending on how much whatever library you're calling drops the GIL. Like what's really going on is that it can access the parallelism at the cluster level, and you could imagine literally doing all of those systematic fills in parallel and then persisting the output histogram or even the output arrays into the cluster memory.
Yeah, that's
even more useful.
Like a win. Yeah.
It's a giant win. Yeah.
Doc?
Who persistifies the cluster and keeps it alive?
That's up to users, and there's some interesting policies that we have yet to explore that are already in Dask. In particular, you can keep the cluster alive indefinitely, so long as your priority will allow it, by specifying a worker rotation timeout, and Dask will automatically retire workers of a certain age and launch new ones in a staggered way to keep your cluster alive by keeping your jobs from not all timing out at the same time with the wall clock limit. And then the user determines what gets persisted into the cluster memory of the resources that they have acquired.
But if I'm going to share this as a service with other users, then the end user's really not going to maintain the cluster, are they?
I mean, right now, since it's the Wild West, they could. All I have to do is share an IP address and a port with someone. And then they can access my scheduler and all the associated cluster memory.
Yeah, I can see why we would be hesitant about that being the status quo going forward. I'd like to point out that using Dask as a DAG optimizer and describing the work and to be done is a separable problem from how it gets, how clusters live and what it runs on. You know, for example, it's possible to run Dask DAGs on Ray, and presumably it should be possible to run it, you know, in some sort of a shared resource that users don't have to maintain, because that's not how we normally work on things. But you know, having the workflow described as a Dask DAG is a step up, because that could be plugged into cluster solutions.
Yes, and in particular, since you have introspection to the DAG, you can analyze it, and if you wanted to, you could probably make some programmatic ServiceX thing that would eat parts of the Dask DAG and replace the nodes that ServiceX provides, for instance, and just get rid of users needing to write those queries.
Yeah, I totally agree. In fact, this is exactly what HEP tables was doing. You know, the user interface, you got to think, because you really want the physicist to have some control over where that boundary occurs. But completely, this is not. I mean, I don't have it for awkward trees or Dask graphs, but made it already for ASTs. So I think this is very much a great direction to go.
Yeah, and I think it was, or just to point it out, though, I think it was kind of manifest, like this is exactly how people write analysis code in Coffee right now, this particular little bit, or, you know, embellishments upon that. But because it's more or less the same, I think adoption is going to be pretty easy. And the fact that the Dask DAG itself is a very common thing makes it a good standard to work on top of for analysis, like what you're talking about, Gordon.
Yeah, exactly. And I also really, I'm really happy that the question of how to balance Dask and Coffee processors is now being directly addressed with some code here, because I think using Dask as opposed to just like a giant spawn. Okay, I'm showing my VMS roots, but anyway, as you know, a giant set of way of distributing command lines. Basically, this is very cool, and I really hope this continues to be as good as it looks as we work through the details.
Yeah. There's obviously some problems and things to hammer out, but it's in talking with all the people developing it, it's always getting hammered out. So we haven't. I think it'll converge pretty well, given how things are going.
Yeah, I mean, this like seems to be moving a lot like forward in the past, like in the recent past. So I think this is a topic we will pick up again in other meetings. I mean, this was like one short look at it. There will be more. Stay tuned, I would say, because I think there's lots of extra things to talk about.
I wonder if maybe, Lindsey, you could make sure, perhaps, if that notebook could be attached to the agenda.
It already is.
Oh, it is. All right, great. Thanks.
Already written there. Okay, let's take Liz and then we'll move on to the next contribution. Liz, please.
Yeah, I was just going to circle back to the Wild West sort of comment. And, you know, you can do the Wild West when you have a very controlled system like an HLT, right? A lot of people are just using bare old CUDA, which would never work on the grid. And it seems to me that this could be a task that is also running on some dedicated infrastructure, right? If it's calculating jet energy corrections in their systematics for the JetMet POG, for instance, and doing it in a continuous sort of way as the data comes in, then it could be on dedicated resources. And what I was wondering is, did you have that sort of use case in mind?
So there's already people in JetMet that, or they're converting their whole derivation workflow to Coffee, and so they'll be able to use this stuff once we release it too.
Okay.
And that's I think a workflow pattern that they're interested in, because it significantly reduces burden on their conveners and all the people doing work for them.
Yeah, I could see that. Thanks.
All right.
So
Thanks a lot.
while you're switching, I just want to say we figured out why the demo didn't work. There was a miscommunication between Ben and I and Tal, and he just didn't have a proper package version number.
We can get back to it at the end if that makes sense.
Okay, if Ben's up for it, I don't know whether or not Ben has time, but he's able to make his demo work, and so we can ask Ben if he wants.
Sure.
Okay, thanks. Let's continue with Elliott, who's going to be talking about workflow topics here, and specifically about integrating machine learning into our AGC pipeline. Elliott, you're going to share from your end. Yes, perfect.
Yes. All right. Yeah. So as Alex said, I'm going to be talking about how integrating ML into the AGC pipeline, and specifically how we can use MLflow to facilitate that process. So sort of why we want to integrate machine learning into analysis grand challenge. As machine learning is becoming more and more used in analysis, we want to provide options for physicists who want to incorporate machine learning into their analyses on analysis facilities. And we need to address both the training and inference sides of that. So the tools that I'm using in this process is MLflow for training and NVIDIA Triton for inference. And if you recall, during demo day 1, I talked about Triton Inference Server, so I've included a link to that in case anyone wants to get back to it. And so today I'll be talking about training and MLflow. So this is a previous analysis grand challenge pipeline, and I'll talk about the modifications that I am proposing. Here is the previous pipeline. So starting with columnar data, going to events selection, going to histograms, statistical model building, etc. So I'm sure everybody's seen this diagram before. And then here is modified pipeline with machine learning. So we need to first train the models that we're going to use in the analysis pipeline. So that's this top part right here. So we start the same way. We start with the same data, and then we need to do event selection. And then we need to pre-process the training features, which involves normalizing features and separating events into subsamples for training. And then once we have the data ready, doing model fitting and hyperparameter optimization for the different models, and then selecting best models for inference. And then at that point, it merges with the original pipeline. And we have machine learning inference that can provide new variables to use for analysis. So what we are using for that is, as I mentioned before, MLflow and NVIDIA Triton. So at the model fitting step and hyperparameter optimization, we can use MLflow to track the parameters and metrics that we care about during the training process. And we can also store models in a way that makes sense. And for this particular demonstration, I'm going to use scikit-learn and XGBoost for boosted decision tree, but really this can work with whatever hypothetically. And then I won't be demonstrating this today, but the way to connect the two pipelines here is through MLflow NVIDIA Triton plugin, so we can transfer the models directly from MLflow model repository to the Triton inference server, and then use them in inference. So, yep, as I mentioned, this part up here is what I will be demonstrating today. And last time I gave a very kind of basic example of what the bottom pipeline might look like. And then for CHEP, I plan to demonstrate both together and how they interface together. So what is MLflow? So it's a tool that you can use to track metrics, parameters, and artifacts that are related to machine learning process while running machine learning code. You can use it to organize models and model versions in a nice way in a central repository. Why do we care about using MLflow? I think there are two main reasons that I've seen in my experience. One, monitoring training of complex models, which may train over the course of many hours or even days. So if you want to track that progress as it's running in a convenient way, MLflow is good for that, and also good for keeping track of model versions during either hyperparameter optimization or different training data, or just any reason you might have different model versions. And then, as I talked about, there's MLflow and Triton plugin, so you can move stored models directly from MLflow model repository to Triton inference server, and this will nicely integrate the training and inference pipelines. So here's sort of a demonstration of how the models model optimization process might look like as far as storing models. So you initialize models with different hyperparameters, and we need to discover the optimal parameters in order to maximize the performance of our machine learning model. So this can be very time consuming, so we want to make sure this process scales. So we want to parallelize it while still keeping track of performance. So we might have an experiment here in which we run 10 trials that have 10 logged models. We'll select the best one and decide to store that one in a model registry. And then we can use a Triton plugin to move it to NVIDIA Triton. And this is how MLflow setup looks like in Analysis Facility. So you start, the user has their machine learning code and uses the MLflow client API. And then this communicates with Kubernetes cluster, where we have MLflow, and there are two main parts of storage in MLflow. We have our metadata storage and our artifact storage with MinIO, and that is where the models are kept. And currently, I think for the demonstration, the model storage is a bit broken, so you'll have to bear with me, but I will run something that works and show how the model storage should work. So the task that I have been working on is assigning jets in TT-bar event to their parent partons. However, this is a bit too complicated to show for the purposes of this demo, so I'm just showing a simplified task, just signal background discrimination using boosted decision tree. So I have a link to my demo. Let me go over to it now. Okay, is this too small?
You know, it's right, the white on with dark lettering is much easier to read, although it's the vice versa when I'm looking at my laptop.
Okay.
I can see it just fine from remotely here.
Great. Okay, so I think I'm going to sort of gloss over some of these cells because there's a lot of detail here, but I'll explain the parts that are important for training. And if you're curious about other details, you can go back and look at it and ask me questions if you have any. So I have some options here. I'm just running on not very many events for the purpose of getting through this demo. So I can specify the number of events I want to train with, the number of trials per model for hyperparameter optimization I want to use, and the total number. I'm training 2 models, so the total number of trails will be 2 times the number of trials, number of folds for cross-validation, and then different things like model name, whether you want to use MLflow, whether you want to use Dask with MLflow. Then I am getting my feature columns using a Coffea processor, using column accumulator. Also note that the features I'm using here probably not realistic to actual physics analysis. This is just, technical demonstrations. So apply a few event filters, make sure I have one VTech jet per event, apply filters, and then calculate features. I will gloss over these details. I've just chose some features that might be interesting. And then I save in the column accumulator at the end. So features and labels, and then, okay. So I am using just TT bar events and WJet events to make this simple as possible. And then I can do the processing step. And
so this part is just extracting the training data, right?
Yes, exactly. So I'll talk about the MLflow stuff with actual training and hyperparameter optimization. So I think instead of running the cells below, I will just talk about them really quickly while that runs. Oh, it just ran, so we're good. So to get what I want out of the output from the Coffea processor, and then I can separate into signal and background just so that I can balance them, because I think the original ratio is like 6:1 signal to background, and I want it to be 1:1. So that's all I'm doing there. And then just a quick glance at the features that I'm using to show separation between signal and background. So number of jets, HT, etc. A few more features, but I won't dwell here because the actual features I'm using are not so important for this demonstration. And then just combining everything, separating into 2 data sets based on even and odd event numbers. So I'll be training 2 models. And then here is the pre-process step, and I'm just essentially using scikit-learn power transformer to make sure the features are approximately Gaussian distributed. And I'm making sure things are separate, so the same transformer is not used for across the different data sets. So I need to provide some environment variables to the workers in order to do MLflow logging on distributed Dask. So that's what I'm doing here. So I provide event variables, and then I set MLflow tracking URI, and I set the experiment name here. And then what I do here is I'm going to set up all the trials that I'm running beforehand and grab the ID of the run number so that I can tell that to the Dask workers when I am running each trial. So I can set the experiment here, and this will create an experiment if it does not exist. And all of my trials are going to exist within this experiment. So I am setting n trials times 2 runs, and saving the run IDs. And so this is just for a Triton inference server. I can okay. That issue with persistent volume, but that's not crucial to this demonstration. Okay, so now I can set up my trials. So I am going to sample randomly from these parameters, and these will vary within each trial. And then I'm essentially assigning trial numbers so that when I feed the parameters into a training, it'll also keep track of which run I'm going to assign the resulting metrics to. So here's an example of that. So I have my run ID and all of my hyperparameters for that specific trial. And then I have this method in which I actually fit the model and perform cross-validation. So I feed it the parameters from above, features, labels, the folds for cross-validation, and then I'm going to give it MLflow client. And then here's my flags, whether I want to use MLflow or model logging. I'm not going to demonstrate model logging today because that is broken, but the option is there, and it did work 3 days ago. So essentially, I'm going to tell MLflow all of the parameters so that it can tell me that all of these are associated with the current trial. I'm going to initialize my model, perform n-fold cross-validation. I'm doing 5-fold here, and these are all the metrics that I care about keeping track of. And then I can log those metrics as a result of this cross-validation below. And using this step, everything gets stored in MLflow. And then I have to, with MLfliant, manually end the run. And then after, if I want to also keep track of the models and have the trained model associated with each trial stored in MLflow, I can do it here. So I can sort of restart the run and log the model here. And I can return the metrics that I care about. And in the case where I don't do model logging on MLflow, I've just returned the models, so storing them locally. So here I will define the folds for the cross-validation and set up the MLflow client.
So the cell that's just disappearing off right now.
Yes.
So yeah, that cell, that did the training?
This is going to do the training. This is just defining the
Oh,
method.
it's just the function.
It's just the function. Yeah, that'll happen in a second.
Yep.
And then I need to set up all the environment variables on the desk workers, and I'll do that now. And then after that, I can run model optimization for model 1. So basically, I'm going to use Dask and give the different trials to the desk workers. And then I'm only training on a few events for the purposes of this demonstration. I give it the client, etc. And now as this runs, I can see this update in real time in MLflow. So I'll filter by start time because I think I didn't delete a previous run that I did, but I can see as they finish the runs with their respective metrics fill out. So ideally, we would also have models listed for every run, but you can see total runtime, it's not really relevant because I set up the runs beforehand, but I saved the fit time as a metric. So you can look at the fit time in seconds, score time, and then the actual metrics that we care about. So I can look at the test ROC. And so this is what we're going to be investigating to decide what the best model is. And then off to the right here, you can see the different parameters for each trial that I'm using. So I have the learning rate, maximum depth of the boosted decision tree, etc. A bunch of different options. So let's see, did this, yeah, model 1 is done running. It found parameters that produce the model with the highest AUC. And then I can, if I'm using model logging, I could then take the run ID from the best trial and store in model repository down below. But here I can just show, if I want to show the score against events that model hasn't looked at yet, I can look down here. So you can see the difference in performance, and note that I'm not training on a lot of events right now. So, and then this step registers the model if I was doing that. And then I won't run this right now, but this is just if I wanted to save the model to persistent volume for NVIDIA Triton. And then I can run basically the same thing for model 2, so using different events. So this is essentially the same steps on different events. And then I can see it populate in real time in MLflow, and I'll wait until all these run and show how you can look at the events.
How can you tell which ones are running?
What?
How can you tell which ones are running?
You can tell, I mean, basically if the parameters are logged, but the metrics are not, you know, that one's running, but I don't think there's a indicator other than that. I could probably create one.
If you click on it, it should show you the status.
Oh, thank you.
If you click on what? When
Like
you say it, what is
the
it?
time? The time happens to be the link.
Okay.
Yeah, so if I can go to a specific run, and this one says finished. But I guess if it was running, it would say status running.
No, perfect.
Yeah. Okay, thanks for that. And then if I wanted to compare across these 80 runs, I can do so just selecting all of them and hitting compare. So I can, for example, if I wanted to look at how the test accuracy varies as a function of max depth, I can look at all of the trials here, and I can do something like look at the test ROC versus the train ROC, and I can see it's pretty linear, and then you can see like maybe at the end we have a few cases in which we overtrain. And we can also, it also has a contour plot feature where you can look at sort of 3D plots of to maybe see correlation between variables, but it's not going to work. I don't think there's, with this particular example, I don't think there are any really beautiful plots, but this feature is there in case people are interested in that. So ideally, after that, I can automatically write config file for Triton, save the models in the persistent volume, and then they should be loaded in NVIDIA Triton. I'm not demonstrating that right now because some issues with that. But and then other option is, as I mentioned earlier, using MLflow Triton plugin. And in that case, we don't even need to load the models in the notebook. We can just directly transfer them from MLflow model repository to the NVIDIA Triton inference server. So I didn't demonstrate what model repository looks like and logging models, but I have a screenshot of what that might look like from a previous run I did in which it did work. So you can go to model registry, and it will list all the versions of the models that you've saved to that particular model name. And then you can see what run it came from and go look at the run details. So I can look and see what parameters, hyperparameters were used for the model. I can see what metrics, the metrics of the model performance, etc. And then from here, using MLflow Triton plugin, you should be able to transfer to Triton. So that's all I have today.
Thanks a lot, Elliott. I think this is a great blueprint for people who have like training needs to adopt, because I think in practice probably people reinvent some of this, so like write custom code for like a lot of the things that essentially like here and also this view. So I think this is really nice, like a nice basis for people to pick up, and it's great to see this working and integrated. Questions and comments? Yeah, for Elliott.
I've got one.
Please.
Unless you want to do Zoom
turn
first.
on the light.
Oh, right. I don't need a light. So the MLflow looks terrific when it comes to you know, you've reached the hyperparameter stage. How about when I'm actually trying to design my network the first time? So I'm not really curious about hyperparameters. I want to add some new blocks or etc. Is that, I mean, it looks like you build the model currently in the Python code, right?
Yeah.
Okay, so would you suggest at that point you still use MLflow as your backend? You just run with one set of parameters, so each run is, you know, trivial in that respect. Is that?
Yeah, you can do that. And also if like you care about just like monitoring training progress, you can like have metrics for each epoch and stuff like that.
Okay.
So, I mean, the parameters can be whatever you want them to be. Like if you want to record information about like
Right.
model architecture.
No, I was more interested in the sort of the development loop. Like, okay, this didn't quite take into account my tracks. I need to add a few more layers, or I need to change, you know, swap out a fully connected network with a CNN. Fully connected couple of layers with a CNN followed by some sort of, you know, attention thing.
Yeah.
And that you imagine just iterating in the Python that feeds the MLflow.
Yeah, and if you wanted to like store information in MLflow about like things that didn't work, you can update a description of each run, or you can like you could log parameters related to the model architecture if you wanted to, like number of layers.
So you can arbitrarily log things in MLflow.
Yeah.
Is that what you're saying?
Yeah.
So I could like add comments.
Yeah, and the other thing is that one of the things it's logging is the commit SHA. So if you happen to be using GitHub and you're hacking along and it's getting better and better, and then it starts getting worse and worse, you can say, wait, which commit was the good one, and kind of revert back to that.
I guess I missed that. Was the model pulled from GitHub? It looked like the model was just
It's not
here.
It just examines your environment to pick up your commit SHA from whatever is like currently. If you have a dirty repo, then it won't work. But if you're committing,
it won't work, of course. Right. Okay, so that's very nice. So you mean even in this environment with the Jupyter Notebook, which by definition is dirty, because as soon as you start executing a Jupyter Notebook, you mess up your environment.
Yes. So
okay. All right, too bad.
One other thing, just briefly, is there's another piece of MLflow, which is projects, where you can define like your environment for your training run. And then there's a command line tool that says MLflow run, and you point it at your project file, and it can run it locally. It'll build the Conda environment to make sure that all your dependencies are correct for when you run it. But it'll also can launch remote jobs. It can launch it on Dask. We have a Slurm plugin. So if you've got a HPC that you want to do training on, and you can, with the same command line and the same code, develop your model locally, and then with just a command line option, run the model off on, a DOE HPC computer. So that kind of breaks you out of the Jupyter Notebook development cycle, but it's quite useful.
Very nice.
Thanks, Dan. We have a question or comment from Brian.
Yeah, what's the envision model within an analysis facility? Are you envisioning everybody, you know, if there's 100 users, there's 100 MLflow instances? Is it there's one MLflow for the analysis facility? I mean, what's the kind of interaction expected for this?
So
So
ideally
ML
with, okay, go ahead.
MLflow is not multi-tenant, and so it has these different experiments, and so you can segregate things that way. And so really it comes down to what's the universe of people that you trust and want to share stuff with. The server itself is quite lightweight, just a little Flask app. And so at NCSA, we're building up scripts to just deploy for every little research group to have their own local MLflow instance, and they're fairly inexpensive to spin up. But yeah, I don't know what the answer is.
It sounds like the answer is, each user, alongside all the other stuff we spin up with them, we should probably spin up an MLflow.
Ultimately, yeah, it's just a nice little Helm chart.
Yeah, I think the real question behind that is, of course, resource contention and how much of what you ask for can you actually get at your job, or when you ask for a job, based on what everyone else is doing. And here you can definitely exact some control by, exposing the GPUs through a Kubernetes operator or Dask or something like that, and having priority system set up, because that's probably the thing to really mind for how we deploy these systems, because we don't want users just covering each other.
I think the resources are somewhat independent of this, as far as I understand at least. I mean, you don't get the resources through MLflow. MLflow just sort of logs everything. So I'm imagining resource-wise, that's very lightweight. So the resource probably sort of still exists independently.
If 50 people launch a hyperparameter optimization on 50 different models all at once, you will run out of GPUs, and that is a thing you need to manage.
Yeah, sure, but that's unrelated to MLflow, other than if you're using MLflow projects and run it on a Slurm queue, then all that's handled through Slurm, which would be probably a suggested way of doing this.
Correct. Yeah. I mean, we need to figure out what our policies look like for that to get decent quality of service and stuff like that. Because the nice thing about MLflow here is that it's made launching enormous GPU hungry jobs very easy.
Yeah. Is that the nice thing?
Okay, I think we cut it here if we continue on our agenda. Thanks again a lot, Elliott. And we're going to switch next to some contributions from Coffea-casa, and starting out, we have Sam talking about Coffea-casa with integrated CephFS.
Yeah, let me go ahead and share my screen. Okay, can everyone see my screen?
Yeah, that looks good.
You're good.
Okay, so this is my first contribution and first time demonstrating, and then big thanks to John and Oksana and everyone else at UNL that kind of helped me do this. So I have a PowerPoint, but I'm going to bounce back and forth so we can kind of explain what's going on. So when you sign into your Jupyter Hub, you are known as CMS Jovian, and your working directory is home. And if I do a DFH, you have about 10 gigabytes to use, and that's all you get. That's where all your files are going to go. So going back to this, we worked on getting a shared directory with CephFS, so you can have more storage, you can share user files between different users, and you can also share files between analysis facilities. So what normally happens is when you log into your Jupyter Hub, there's a ton of configuration that we have done that mounts your secrets, it mounts all your stuff. And what I did is I added in a function into our Python creation hook that actually sends your information to the Cube API, and it finds a mount on tier 2, matching with your username, and then it goes ahead and mounts it into your notebook. So if I go back to our development environment, and I do a df-h, I have my normal home in here, but I also have a mount for my user because I had a directory on the tier 2. So if I go into there and I do an ls, I have all these test files, and going into the tier 3 facility via SSH. If I go into my user, I have the same files that match up. So I'll go through a demo and I will create one and show that's actually linked. I would just want to kind of explain it a little more on how it works. So the first step of Python is to take your user, which in this case is test user. And we basically have the email address and the Jupyter Hub name to match that to the storage. So kind of some of the problems that we were facing is how do we take this and slice it up correctly to mount that? So right now what we have is we just have regex doing that, and it's going to match it up to basically either T user, test user, or any variations of that. And then after that's done, we go ahead and we take the user's information, the volume information, and we go ahead and we use the Cube API and we declare persistent volume before the pod is created, and then we create the claim and we mount it on the Jupyter pod creation, and all the permissions are taken care of using bindfs. So going back to here, if I just want to make a new file, make my file 5. That's there. Go into the tier 3. It matches up. So now we have, instead of just that 10 gigabytes, we also have our mounted storage, which right now is 1 gig. We'll eventually dynamically provision that to be whatever size we want. But I can then go in, say if I was on the tier 3 and I edited this, did not mean to open that as read-only. I'm gonna do that on the hub because I messed up my terminal. So then that'll match up on the tier 3. So now we have that mounted. We can mount that to, say, other users. We can have multiple users on the same mount. We could even create a PV and PVC for each user if they don't have one already. So that's kind of what I've been working on for on the development side, getting a shared file, CephFS file system for when you sign into the pod. There's a lot that went into creating this. Obviously, we had to get the API working for inside a pod to talk to Kubernetes, and then get that back out to match that up correctly. So then kind of the next steps is we want to have it a little more robust on evaluating the identity, and then of course the creation of a shared directory if we don't have that already. Any questions?
Thanks a lot, Sam. Yeah, we've gotten here. Go ahead.
Let's see, is there anybody from Chicago, the analysis facility in Chicago here?
Yep.
I have no idea who said yep. Sorry,
It's
Rob.
Rob.
So
I think Feng Peng is here. I think Ilya is here.
Okay.
So
Yeah, I just wanted to ask. So my observations are in Chicago. Is it using the same technique, right? Because already there are disks that are shared between like the Jupyter Hub instance and the Coffea-casa instance. There's this data disk, right? Is this using the same thing, or is this like a different effort?
Feng Peng's gonna have to answer that.
Yeah, I guess it's different. We just mount the CephFS to the Jupyter notebook pods. And
yeah, okay, that's right. So the difference is that on the Coffea-casa in Chicago, I can see everybody's data disk, and here you only get to see your own user's data disk. Is that correct?
Yep, you'll only get whatever matches for your username. So if your directory is, first name, last name, and your username is first name, last name, that's all you get.
Okay.
And then
So it might be worth working a little bit with Chicago to explore having also this other form. And the reason is that, for example, when I've been working on the neural network training with my grad student, it's been extremely convenient that, they just put all their data files into their directory that they're allowed to write on. And now I can access those data files. I can see them from my Coffea-casa pod. And so that's a super convenient way for a small analysis group or group of people to share some small data.
I mean, it's like not really a problem to do this, because what we were trying to do is also, so we already have a lot of things that are available from our tier 2, like batch queue and etc. And currently we have an issue that actually all our users are CMS job. So whatever person is logging in, all of us will go and then accidentally can kill jobs. We can actually. So the next step we want to do is actually to try to have more personalized approach when actually users have their own. So when you submit your jobs, they're actually held or Shadura.
No, that totally no.
And it's kind of one of the
right.
building blocks that we require is that.
I'm not trying to say that that's not the right thing to do. Yeah. It's totally the right thing to do. It just occurs to me, it sounds to me like some extensions to Coffea-casa have been made at Chicago, and it might be worth linking the two groups together, because some of the features that are available now on Coffea-casa in Chicago are ones I think we would want.
I think like we are doing exactly similar approach with Fermi. So I know how it was done. It's just that for us was important that, for example, I know that I'm not sure like Fermi, you don't have any way kind of like match the local, so the user ID on the analysis facility. Where, for example, Alex has 1 terabyte, and to match the from Coffea-casa the local user, right? You just like kind of like fix permission.
I think the really big difference here that's getting skipped is at Chicago there is a separate user database, right? There people get accounts at the facility. You link it, it's through the Globus account, it's through the Connect API, and you have a unique UID. The difference of what Sam's doing at Nebraska here is there's no local account, there's no Unix UID for Sam. And instead, it's all managed through IAM at CERN. So the kind of the fork in the road between what Chicago's doing and what Nebraska's doing is even further upstream. There's kind of there's no concept of Sam having an account at Nebraska. Rather, it's all handled by the CMS IAM server. So I think that's where the fork is, and then that's where the different implementations.
So does this mean that in Nebraska you basically have to recreate by hand all this account infrastructure?
No, the difference is that there's no account infrastructure being recreated. So that's maybe part.
Right, but in order to do things like make sure the Condor jobs come from the go to the attributed to the right person, etc. It sounds like you have to like put all that in yourself, right?
No, I don't think that's the right way to think about it. It might rapidly get really technical for this crowd, but
sorry, yes, we can talk later.
Yeah, so I think the take-home message is this shows a way to do the shared file system pieces without having a Unix ID or a UID for the user at wherever that Coffea-casa is being
right.
Right, because to answer your earlier question, that the next phase of this is to take the group information out and make it so there's also group shared directory as well. So that's where it starts to get interesting for you is if you create a group at the Atlas level, or in this case the CMS level, that group and the storage directories can get propagated all the way down.
Yeah, I like that. The thing I like about the way the Chicago one is arranged is that, you know, at 3 in.the morning, if I need to, you know, share something with somebody and we have never shared before, I just create it with the right permissions and they can see it, right? There's no overhead involved, right? Nobody else, no account manager or anything needs to get involved. But okay, so thanks for explaining that, Brian. I think I understand a little better what the differences are here.
Let's continue with 2 more hands raised here. Ben, you were first.
Sure, Puppy, quick question. Are these mounts available in Dask? Both? Is there, I guess we run Dask in Kubernetes and also Dask out on the Condor. Are these mounts generally available there too?
I don't think we worked on that part yet, so no.
Okay.
For Chicago, it is, yes.
For us, we have like. Go ahead, Brian.
Or I was just simply they're available through xAOD, right?
All right.
Okay, then, Bert, let's take your comment or question.
Yeah, so both, I think both a comment and question. So I was actually raising my hand when we were talking about the UIDs. So at, you know, at a national lab where we do have the fixed UID like Chicago, you know, we are spawning notebooks. You know, we took the different approach of spawning notebooks as the user, and then we can mount with using Unix UID GID. But this work is kind of relevant for when we're thinking beyond that for this more ephemeral stuff and how to share disks. It's also an interesting idea. You know, we're looking at, you know, so we're a multi-tenant facility. We've got not just groups, but, you know, 50 to 100 different experiment shared areas on NFS that people want access to. And so we're looking at ways to do that. That'll be migrated to Ceph at some point. So this might plug in nicely with our, you know, with our schedules at Fermi Lab to be able to, whether it dynamically generate PVs when people log in and sort of link those to existing Ceph spaces, which will reduce our operational overhead, or it's an interesting idea that I hadn't really thought about till I saw this work. So thanks, Sam.
All right, thanks, Bert. Any last comments or questions? Anything else here for Sam? I don't see anything. Okay, then thanks again. And we will move on to our last contribution for today. Another one on Coffea-casa, and this one is about dependency management from Oksana.
Exactly what nailed the ServiceX demo.
Yeah. we can get back to that if you.
Yeah, Ben said he was up for it.
Yeah,
so
let's
if
see
we have time.
Okay, then I will try to do a quick.
No,
I didn't mean last. Sorry.
Oh no, I wasn't. I was laughing at dependency management because this is like a real pain.
Yeah. So this is like a hot topic that we trying to understand how to resolve. So I will just like there's something that we collected, and probably it's from the experience of people who are running already analysis on Coffea-casa, and particularities of how it is organized. That, as you saw from the SAM talk, we had before only persistent volumes available of 10 gigabytes per user. So you couldn't kind of easily share your environment between your like Condor workers and etc. So that is like, let's say, what users dream about. So first thing, we saw that they want to pip install their packages quickly between, let's say, their notebook and between Dask Kubernetes workers and Dask Condor workers. They also want to ship their Conda environment easily without going through some kind of, through Condor settings or something. In analysis, I saw that users want to ship their workflow or data files or other Python files, like small files, some say 50 megabytes, maybe maximum. And what are the options we need to think about, because kind of like it's still ongoing work, so the use cases is still would be interesting to hear from you. So there was a dedicated discussion on the Coffee, where was posted a lot of different cases how you can do this from Dask, but they always had some issues of or synchronization or not really scaling in the terms of when you had more workers, then you probably lose your dependency that you, or the code that you shipped on this worker. So as I told, until now, Coffea-casa didn't have shared file system. So usual approach that you see on LXPath when you do pip install, whatever, and then it's available everywhere, was not like working. So how actually, to explain you a bit better what we are looking into, so what is the recommended way by Dask? Dask, they're recommending to do any customizations you want to do. So maybe it's also useful for you after to understand something. So it's through the plugins. So they have like 3 types of plugins. One is scheduler plugin, which is basically usually it's used for like diagnostics or some measurements or logging if you want to have like specific logging on the scheduler side. It has a full access to scheduler, the scheduler, and actually could affect some, as people say, the core scheduling. Worker plugins is interesting because they would allow you to have a custom code that you can push into the like worker like life cycle. So during setup, because it has a different cycles, like during when the tasks are moving here and there, or at the end when the worker is kind of like shut down, teared down. Nanny plugin. So I don't know if you're familiar with how works Dask. So we have scheduler. We have actually worker itself that we are starting with the different arguments and so parameters that you pass there, like memory, number of cores, number of threads, TLS, so certificates and everything. And then you have actually a nanny. So nanny is a kind of like a small tiny utility that actually runs and it controls the worker itself, so Dask worker. So it allows to start it, restart it, shut down. So like this, for example, it allows us to run some kind of like adaptive scheduling and all these things. So nanny plugins are the best, let's say, from because what this allows, it's basically do the same thing as worker, but it also allows to run some code before worker starting or restart worker but painlessly. So basically you don't lose the worker skill, but the worker could like restart the state. Maybe something useful for you because there is always this question. So there is interesting options on the worker built-in plugins that we have. And one is like pip install. So it's kind of standard built-in worker where you can basically, if you're on Coffea-casa and you have your cluster, you start your client, and then you can install whatever you want. So here, for example, I had 35 workers and I installed scikit-learn on all of them. And as you see, here was like, yeah, everywhere got installed. There is Conda install as well. So who wanted to ship the Conda, but it's not available on Coffea-casa because we are not on the latest Dask still. But I will make sure to make it like available 100%. Then, okay, the other interesting option, as we told that we have these 90 plugins and we would like to try it. It's a very popular approach. I saw it in CMS Coffea-casa in some analysis, people were using it. It's basically a built-in 90 plugin which called upload directory. And it allows you to upload your whatever directory you have with all internals to your worker. What is happening on Coffea-casa? Why it didn't work for us so beautifully? So as you see, we have two workers. One of them is Kubernetes. Another one is on Conda, a Conda worker. And if you run it, basically the issue is that you need to have some way for scheduler to communicate nanny because it's nanny plugin. And from this point, you will see here that we will get timeout because basically there is no possibility for scheduler to communicate with an any. So there is was a lot of.
Wait. Sorry. You're just saying that the Dask has a bug in it?
No, it's the way how we do. So we have Condor workers, which are.
So it's just the Condor workers that are causing the problem.
Yes, for Condor workers, because we don't have open port for nanny, and there was no. We added one more option.
So you need a proxy.
One more
is
option.
that basically the difficulty is the pipe between the Condor machine and whatever this machine is?
Yeah, but it was easy to do because Dask is pretty modular. You can add whatever you want. So there was batch from John, which is like nicely enabled. Advertise for scheduler the address of nanny to talk to, and now you could see like this is. So I have two different open data facilities. One with a broken. Let's see, here's broken. This is what everybody saw. If you saw, I'm sorry. And now with a new fix, basically, okay, we'll just rerun. So we see we have two workers, and here we see that how it works when you do a flagging. So first thing, you need to always register plugin. You register your plugin with a name, with some parameters. You say nanny true. It's important. Nanny true. And after this, you could see that the plugin was registered successfully, and we got results from both of the workers. The other thing is that there was sadly.
So is that a patch to Dask itself?
Yeah, we will open PR. We will.
No, I understand. I'm trying to understand where the patch was.
Yeah, the patch was to able to add one more option to the worker, where you say, okay, this is the address of nanny, so scheduler knows which how to communicate to nanny, and then basically in such a way you could see, for example, here we could see in the logs.
So does that mean your data center is configured with a special port that does the forwarding or something?
You just in Coffea-casa settings, so we just open particular. We have already port for the Dask worker scheduler. I mean, it's a normal practice to open some ports.
Of course.
So one way to think of it, Gordon, is the worker listens on a randomly assigned port because there could be many workers.
Right.
And there's a way to tell the scheduler what that port was. But if you give the nanny a randomly assigned port, you couldn't tell the scheduler where that was.
Oh, so normally the nanny will listen on a specific port, but right here for this, you need to do a random port, and there's just no support for feeding that information back.
Yeah, there's some more.
You said?
Yeah, that's the gist of it. There's some more technical pieces, but I don't think it matters at this level.
Okay.
So then the other thing is that Andrew is now in Lake Louise, conference, and he did but it just, I wanted to show. So he did a very nice development, basically, as you saw, that anybody could develop their own plugins. So you can, it's really super easy. Here, basically, he was trying to explore possibility to have he called it distributed environment plugin that we added in Coffea-casa. The problem is that he's a developer of top coffee analysis.
Oh, so the editable,
And the thing is that when you develop in quick way, fast iteration, so there is a first problem is that you need to make sure that the code is properly synchronized. If you don't want to ship everything, but you just want to add one file on the top, so to make it more customizable. And it's heavily based, so basically the same kind of signature on the upload directory. And then it was idea, so it's a first iteration development, where after this we would like to have better checks if you have what you have on your kind of notebook and what you shared is kind of exactly, so to have better sync between worker. And okay, so I tried to run on Top Coffee example. So yeah, and also it supports much more complex structures. So when you have a lot of directories with subdirectories with a lot of modules. Then how the Dask is handling import itself, it's sometimes not very clear, at least what Andrew explained me. And in his case, he told that, okay, here, let's say some small part of the analysis, like get info, and basically he's printing keys from accumulator or something. But the goal is just to show here that it's kind of like much more transparent and easy dependency management that we have. In addition, that we will have shared file system that will allow you, because we will have it available on the both Condor workers, if it is in Kubernetes or through xAOD, like Brian told, you can access because it's part of like AGC. I was saying, Alex, that AGC dataset was actually there, so we can mount easily as well, but you can access to xAOD as well. So it's the first steps, and now we will. So we tried already. I tried to run it on AGC together with Alex. It didn't work smoothly because there is some issues with preprocessing, at least. So there is on Coffee side. We will need to do a better debugging.
When you get to the point where you have these file system mounts that we were just talking about, could you have if you had your environment there, it would be visible to your Dask workers. Could you do something, pretty trivial, as opposed to having to ship all this data? I mean, CephFS should work well if it's being beaten up by lots of simultaneous workers.
Yeah, ideally, that could
and
be.
Just avoid the whole upload. You just need to transfer a link that says this is where your environment is. Please pick it up here.
Yeah, but from this point of view, I think it's important to explore all possible ways because
I'm not sorry. I was just wondering if that opens up another possibility.
It's definitely opens, but also like in such a way, I would say. If in case you have some problems with a shared file system or whatever, it's kind of the recommended way that Dask was pushing a lot. And actually users are using it. They say it's pretty smooth. It's just that you sometimes have this, as you see, like not open port or Dask was not supporting. Because the problem of Dask is that it supports very easy cases. Like we have local cluster, we have Kubernetes cluster, perfect. They never think about people who are going to pipe like 200 terabytes, have Condor workers here, there, shared file system. So we are possibly always exploring these kind of like corner cases.
And Gordon, I don't think the shared file system actually solves the problem at all, right? The question is, how do you have if you have a cluster of Dask hosts, how do you maintain a consistent environment? So if I write out, migrate package version 1.2 and into the shared file system, what version am I processing it with? Is it 1.1 that was there when some of the Dask
but this is the point, is that on the shared file system, since it mounts at the same place everywhere, you just now let your worker know it should pick the environment up from the same direction.
But that's not how Python works, right? What you loaded was was at start whenever the Python interpreter first tickled that particular directory. So
but that's what the nanny process does, right? Is it restarts the worker after you futz with the environment.
And that's that, but maybe the point is that's what this is doing here, is allowing you to keep a consistent environment, or at least being able to kick out workers that don't have consistent. So I think that you don't want to focus on distribution of the files. That's the least important part. The really important part is managing your cluster to have a consistent version of all your packages.
Oh, I totally agree. What triggered me to think about this was, for example, having to deal with editable Python packages when you're developing the package at the same time that you're running. So this environment upload, I can't remember the name, I apologize.
Directory.
Yeah, environment upload directory. right? Because now you're getting to a situation where things are getting tricky and you're having to support all these edge cases. Whereas if you just handed your environment and everybody read from the same file system, all your Dask workers, you would automatically get these edge cases would automatically be included, and you wouldn't have to write special code. That was where I was going.
But that only works if you never want to update the environment while the Dask cluster is working. This is what we saw with a lot of users: is they'd run a bunch of code, change their environment, and then run more code and be surprised that they still got the old environment.
That's a very good point.
That's really, it's the dependency management and making sure that you get
and time management.
Yeah, and the side effects of, do you move the bytes over a shared file system, or does Dask move the bytes? That's more of an implementation detail.
Right. Well, it's figuring, the thing I was going after was figuring out which bytes to move. Right. And that was what I was trying to work around, is how could you make that protected? But you're totally right that I would never stand still while my Dask jobs are running for an hour, and would probably totally mess up source files and make them incompatible. That's an excellent point.
All right. Do we have other comments or questions for Oksana here? Okay, if there's nothing, thanks, Oksana. And we can get back briefly to Ben. Ben, you're back? Yes, I see you're back. So if you would like to, then let's get back to the very beginning of our meeting. Let's get back to ServiceX.
Let me see. I mean, it's not terribly exciting, but at least for completeness. All right, so here is my one example of getting it of an xAOD code generator. So I've specified that my code gen is Atlas xAOD. There's a hint that we have to throw in for the moment that says, oh yeah, this is an xAOD style backend, or kind of interact with it as an xAOD style backend. And then I have to ask for a root T-tree to come back. And if I run this, off it goes. And so it's just going to get interesting to think about how we sanely allow users to say what they want and make sure we can get stuff back. It probably gets easier once the xAOD transformer is capable of also writing Parquet. Then everything is symmetrical, at least.
And I guess Ben, it's worth pointing out, right, that this is an uproot. Traditionally an uproot backend that you're asking for xAOD from.
Yes.
Yeah. It takes about a minute to process this query.
And then I've got a separate function here, which uses the same endpoint, uses the uproot code generator, and then gets back this. Unfortunately, this depends on a CERN open data. Oh, cool.
Oh.
Hey. Nope. This is yeah. It ran. I have a bug here
in the test.
In the test. So but other than that, it did get back the results, and yeah, we need a better uproot smoke test, because this depends on a CERN open data file that is often not accessible inside our analysis facility. Who knows? So there you go. It's still a little clunky. You got to figure out the user experience, but hey, we're getting there. So thanks, Gordon, for.
When will this get released, then?
Not until the front end is ready.
Yeah. Okay. So, but let me ask this: at what point does the front end become critical path?
What time is it right now?
Okay. So you're basically ready to push the button if the front end was released.
Yes.
Okay.
And then it'll be fun how this is going to probably wind up breaking existing analysis.
It shouldn't. unless you try to alter the backend on an old version of ServiceX. But you know, if you make a minor modification to your ServiceX.yaml, in some cases, in other cases, you won't need to make any modification. It should just work.
Okay.
Without any code changes.
Yeah.
Is the deployment easier? Because I imagine before, if you wanted to support multiple transformers, you had to like deploy them all separately. Is this sort of easier now that you just, as the person doing the maintenance, just deploy everything all at once?
Yeah, the big thing, I think, right, Ben, the big thing that this does is the people who are running the analysis facility have less to do.
Right.
From your point of view, it doesn't change the capabilities, at least not as it first is going in, but it makes it easier to add new capabilities. Did I summarize that right, Ben?
Yeah, I mean, it's no harder or easier to deploy an individual ServiceX, but now you only have to deploy one instead of two, which we've had to do in the past. I think we've even had more than that in some places.
And once we come up with fair sharing, it will be possible to do it.
So the resources for the different deployments, for the different transformers are all shared now.
Yes.
So, yeah. Okay. All right. Any other questions, comments, Ben, from you or anyone else in the audience?
While I've got the microphone, I put into the DOMA channel in IRIS-HEP about scheduling the Madison thing around CHEP. Just want to put an ad for like, we need to choose a date because I'm trying to plan some other things.
Oh, I think a date's been chosen, right?
Well, so
I've heard rumors.
Let's wait a few seconds. Well, so the story is that there's a CHEP in the second week of May. There's a pre-CHEP workshop Saturday, Sunday before May, and we were hoping to have an in-person workshop with Zoom available on May 3, 4, 5, ending early enough on Friday, May the 5th, so that you can easily make it to the pre-CHEP workshop if you are interested in that. We couldn't completely finalize the dates for that yet. We assume that there will be no collision with another event that may be going on in that first week of May. So we were tentatively fixing May 3, 4, 5. I think
why can't you fix it?
We don't have like 100% confirmation that we don't get a crash. But Brian, let's see whether we have.
No, wait, you're not going to get anything better than we have now.
Yeah, I was going to say, I think we're at the point where we can just say, go ahead and confirm.
All right, official announcement, AGC workshop happening May 3, 4, 5 in Wisconsin-Madison. You're very welcome to join us there in person.
When does the 5 end? When do you define early enough?
Right, so we presumably it will be lunchtime-ish, say 12 o'clock. I had a look, there's flights in the evening that bring you to pre-CHEP, which starts only in the afternoon of Saturday. There's also flights in the morning that bring you
from Chicago.
Saturday morning, yes. So we definitely, since we
Have
are
you
all
driven from Madison to O'Hare near rush hour? Anytime near rush hour?
I have not.
How did you do, what was the flight coming from Chicago?
The flight is from Chicago.
Okay. Yeah, you need significant padding because that's a real drive. Doug is correct.
And it gets to be a nightmare near O'Hare. That's even worse. It's a 2-hour drive on a good day. Then add traffic.
Which is, another 1.5, 2 hours.
Okay, so there is a 6 o'clock, I think, flight.
Okay,
evening
that should work.
Yeah, having done this many times, my recommendation is having 5 hours between Depart Madison and Wheels Up at O'Hare, and that gets you plenty of traffic time and plenty of things go wrong and all the
I'm taking the morning flight from Chicago to Norfolk, so I'm just putting a whole day in between.
Yeah, most times you end up with lots of time O'Hare, but 5 hours is my safety margin.
So Lindsey, you have already a flight from Chicago to Norfolk?
Yeah, it's like at 7 in the morning or something like that.
On Saturday?
Yeah, on Saturday.
Oh, then we wanted
Yeah,
to
exactly.
say
Yes,
the same.
the
Yeah.
alternative, right? The alternative is going into Chicago on Friday and then like leaving early Saturday. So I think Doug, the message is a lot of us are going to this pre-shop workshop. We will make sure the schedule is such that everyone can make it and doesn't have to rush. So this will definitely be taken into account.
So I am feeling like, I need to buy plane tickets almost immediately. So I'm just going to make a series of assumptions.
Yeah, and we also might all be taking the same plane in the end, but there's not that many options, right? So, yeah.
And there is the bus problem.
Okay, this we'll follow up with an email so that this is more broadly announced. We are looking forward to seeing you either in person if possible or online then via Zoom. This is going to include, amongst other things, also like a demo day type format, probably a bit longer. But yeah, expect more to happen then. Come see us beginning of May before CHEP and also at CHEP if you're going there. All right, anything else for today? I think we're at the point where we can close otherwise. Thanks a lot, everyone, for connecting, for following, for the discussions. Thanks especially to everyone who worked on preparing all the demos here. It's a lot of work that goes into those every time that is often very much invisible if you're just looking at everything working, because all the hard work behind the scenes doesn't really come out from that. But I know a lot goes into that. So thanks a lot to everyone for working on all of this. And we will be in touch more about the workshop soon. Have a nice weekend. Bye-bye.